All right, we should probably start. Before I start, can one of my TAs tell me if my audio is fine? And while that is happening, I think I'll wait for at least one more minute for people to join in. Okay, folks, welcome to Machine Learning, the Fall 2020 edition, which is going to be entirely delivered to you through live streaming. I see that there are about 90 of you here, and there might be a few more on the YouTube live stream. And I'm assuming that as we go along, more people will join in. But I'd like to get started. So welcome to Machine Learning. Before we talk about anything technical, I want to make sure that because this is a somewhat new kind of class, I want to make sure that the ground rules are in place for a smooth online interaction. So let's just spend a little bit of time talking about classroom mechanics. As you're definitely aware, the class will be offered via Zoom for the entire semester. And to streamline things, please use the chat feature in Zoom to ask questions. If you are not sure where the chat feature is, I've added a link on Canvas. There should have been an announcement that went out that kind of gives you pointers about how to find these things. Also, by default, you may notice that your microphone is muted. Please mute your microphone if you're not speaking. This way, this will avoid any issues with audio feedback and such things. But if you do have to speak, please don't forget to unmute. And I think if you press the space bar on your computer, it will temporarily unmute you. You could use that. You don't need to keep your video on unless you want to, in which case I get to know you. By default, both your audio and video will be muted. Just because this is an online class doesn't mean that this is going to be passive. I really want to try to encourage class participation. Participating in class will help you understand the material better, and it will help you, navigate some of the complex things that we will consider. So if you feel like you have a question or you have a doubt, I'm sure there are many more in the class who have the same question. So, just ask the question. In order to participate in class, we will be using the chat feature in Zoom. So you can either type your question in chat and either the TAs or I will respond either through chat or we'll bring it up in this conversation. Alternatively, if you feel like the chat is too limited to type out your question, you can just say, I have a question in the chat, or you can raise your hand. There's a raise hand feature in Zoom, and one of us will call you, and you can unmute yourself. You can ask the question, and this will, this will become part of the class. There will be occasional polls in Zoom. This is something that I'm trying to understand, and to be honest, I'm not entirely sure how well it works. I'll be trying it out later today, and if this works well, I'm going to try to incorporate more polls in the class so that you get to participate. And of course, this is a new kind of medium. So we are open to suggestions. If you think that, we are not doing something well, or if you think you have suggestions about how we might improve, or if you have any new ideas, please contact us through Canvas. I'll talk about class communications later on. Okay, so now that that's out of the way, let's let's go to the topic of the semester, namely, what is machine learning? So that's the main topic of the entire semester. And our goal today, and in fact through the entire semester, is to understand learning, is to get a sense of what learning is, either of the machine kind, mostly of the machine kind. But along the way, I would like you to also think about what learning is more generally. We will touch upon some philosophical points along the way. So to get started, let's play a game. This game is called the Badges game. The way it works is the following. In 1994, there was a conference on computational learning theory. If you attended a conference, you'd know that all attendees get a conference badge with your name and affiliation and such things listed on it. In this particular year, every attendee got a badge, but their badge had a mysterious plus or a minus on it. Now, it was not clear at first glance, looking at your name, why it got a plus or a minus. Only one person knew why the function that generated these labels, and this was the Chaim Hirsch, whose photo is here. And the thing that all the attendees were assured of is this particular choice of whether the person was labeled as a plus or a minus depended entirely on the attendee's name. So given this, then the question is, how did this happen? The task for the attendees is to look at as many examples as they wanted, as many name tags as they wanted in the conference, and to discover the hidden function along the way. Of course, this was also supposed to be a sort of a social mixer, which is always helpful in conferences. But there is in some sense, there is a underlying machine learning problem here, which made it a fun game. So what we're going to do now is we're going to try to play this game. So just as an example of some of the kinds of rules that might have been used, the rule at the top that I'm pointing to right here, I think this was the rule that was used in the conference. If the second letter of the first name is a vowel, then the label is a plus, otherwise it's a minus. Or another thing could be, if the first name is longer than the last name, then the label is plus or the label is minus. So what I'm going to do now is show you some names with labels and try to get you to think about what function I used in order to generate these labels. So we have what in today's terminology might be called a data set. Claire Cardy is labeled as minus and Peter Bartlett is labeled as plus. So the question for you to think about is, how did I generate these labels? And more importantly, what's the label for something that's not in this list? What's the label for Indiana Jones? So this is where I'm going to try to enable a poll. So let's see if this works. I've launched a poll, and on your Zoom windows, you should be able to assign a label. So what's the label for Indiana Jones? So please spend a few seconds just voting, and I see that a lot of you are already selecting votes. I'm going to give it a few more seconds so that you can get yourself comfortable with the mechanics of polling in Zoom. And almost all of you have voted. I'm 3, 2, and 1. So this is an interesting set of results. So I hope you can see the results that I've shared. What we have here, so in case this doesn't make it to the video, is Claire Cardy. So the 53% of you think that the label should be a plus, and 47% of you should think that the labels are minus, and that seems about right. There is really no information here. And the question that I would like you to think about is, how could you possibly know? I mean, I just could have picked up any function. So another possible option here is maybe you could have just told me on chat, there isn't enough data. I don't know. I mean, I deliberately didn't put that thing on, put that option in the poll. So maybe you need more data. So let's say you have more data. So let's say I add 4 more names with labels. And now based on this, and one thing I can assure you is all of this, there's no noise here. This is perfect. So again, we can do the same poll. Let's spend maybe 30 seconds on this new poll where you're asked, what, based on all this new information, can you guess what's the label for Indiana Jones? So let's say you have more data. So let's say I add 4 more names with. So Mattia, you must mute yourself. Yes. While we do this, so I'm going to wait for a few seconds, and there are the votes are coming in. And in essence, while people are voting, I want you to reflect on the fact that this is what we will be asking for the entire semester. We'll be asking machine learning algorithms to do. This for the entire semester. What we'll be doing is we'll be giving some data and asking algorithms to somehow discover the function that was used to assign some labels to those examples in the data. And this time, interestingly, perhaps not surprisingly, the poll is a little slower. Some of you you're taking a little bit more time than before because there's more data. All right, I'm going to stop the poll right now, and let me share the results. It's still roughly equal. There is maybe a slight hedge for plus. The 56% of you think it's a plus, and 44% of you think it's a minus. So maybe one thing we could do is, can someone guess? Maybe just one person, raise your hand or use the chat, preferably use the chat on Zoom to guess what's the answer. So Alexander says there's an answer. Maybe could you type it out, or you can unmute yourself and say it out.
Can you hear me all right?
Yes.
My initial guess is that positive labels are based on the even number of vowels in a person's name. And if they're an odd number, it will be negative.
Okay. And does that fit? I mean, you just came up with a very complicated rule that I'm not able to go too fast checking, but does that fit all the?
It does if you include Y as a vowel.
It does if you include Y as a vowel. Okay. So Claire Cardi has 6 vowels and it's minus. So maybe not. But actually, let me just tell you that's not the function. Even if it fits, it's not the function, because remember, the goal here is for you to read my mind. I came up with a function, and there might be many functions that fit these 6 examples, and it still might not be the right function. But that's a very good guess. It's a rather complicated guess, and I'm impressed that you were able to test that out so quickly. In fact, I'm not going to tell you the function right now. There is a link to the full data on the class website, and I want you to take a look at it after the class and take there are about maybe 300 names with labels, and try to guess what the function was. Try to guess how the names were labeled. But the point is, in some sense, this is what we are asking algorithms to do. So, it's a useful toy problem to have in mind as we encounter more and more algorithms. So let's go back to the question. What is machine learning? Machine learning is everywhere. You're probably already using it, or you're probably already depending on it if you're ordering things online and you are relying on recommendations, if you're using Google Translate, or if you're if you, like me, depend heavily and almost implicitly trust your email spam detector, you are essentially a client of machine learning. Today, it helps us figure out whether an email is spam. Machine learning systems are at play when they put these little boxes around the faces of people and ask you to identify them on social media. They are in play for recommendations for movies and things to buy. They drive a lot of automatic stock trading. Machine learning systems are surprisingly good at handwriting recognition. There are multiple billions of dollars being, at stake when ads are being placed, and the decisions are, of course, not made by humans, but some algorithmic components. If you want to read a Dutch website in English, you can go to an online translation system like Google Translate, and machine learning systems are essentially driving that. Self-driving cars, depending on whom you ask, are either around the corner or they might take forever. But definitely the technology that is driving it is machine learning. Machine learning is making inroads in medicine, in understanding what genetic markers correspond to what kinds of conditions and such things. But what is learning? So the goal for today's lecture really is just one thing. Our goal is to try to define what machine learning is, and along the way, try to understand how the definition evolved over time. Perhaps the oldest mention of machine learning in an academic venue of the phrase machine learning was in this really, really cool paper from 1959 by Arthur Samuel titled Some Studies in Machine Learning Using the Game of Checkers. In that, Samuel writes that programming computers to learn from experience would eliminate the need for programming effort. And this he called machine learning. And the paper goes on, and at the end, it talks about the differences between just memorizing or rote learning and generalizing. And this is a discussion that is still active today, and this is a discussion that we'll have through the semester. And in the end, he concludes that based on the experiments in the paper, he believes that the learning schemes, like the ones described there, would become economically feasible enough to be applied to real life problems. And this was in 1959, which is very impressive. Moving ahead, in 1983, Herbert Simon, who might be the only person ever to get both a Nobel Prize and a Turing Award, he got a Nobel Prize in economics. He said that learning denotes changes in a system that are adaptive. And by that, he means these kinds of changes enable a system to do a task or maybe other tasks from the same population more effectively the next time. So he's envisioning a system that encounters a sequence of tasks as they go along, and as it performs these tasks over time, it improves. In some sense, this is perhaps the most important lesson here. Learning is generalization. Tom Mitchell's book has a somewhat more formal definition of machine learning as a well-posed problem. A computer program is said to learn with some experience E with respect to a fixed collection of tasks, let's call it T, and a performance measure P. So we need to have decided on what the performance measure is upfront in order to even think about what learning is. The program is set to learn if its performance in these tasks, as measured according to the performance measure, improves as the program encounters more experience. Once again, Mitchell's definition of learning is not about doing the task it saw before well, but it's about generalizing to new tasks. Learning is generalization. You might, for example, what we want is we want a computer program to look at these 9 images of dogs and identify that they're dogs. And moreover, it wants to, or alternatively, you want the computer program to look at these 9 images and learn the concept of a dog. But it's not enough to just look at other dogs that look like this. Think about how you and I generalize. We may look at these 9 images or dogs of this kind and call them, correctly identify them as dogs, even though they look very different from each other. But we might even look at something that looks very, very different and still discover that it's a dog. So this is roughly what we want our systems to do. This kind of technology is the future. It gives automatic systems the ability to perform a task in situations that it has never encountered before. So this is, in some sense, a new way to think about programming. In traditional programming, we have to think about edge cases. We have to think about all kinds of inputs that a program might encounter and explicitly deal with how it has to, how it has to process those kind of situations. Machine learning allows us to think of programs that can acquire capabilities that didn't exist at the time that the programmer was working on it. This style of programming, this way of thinking about programming, allows us to build programs that interact robustly with messy data. And pretty much all data that we collect is going to be messy. And because of this sort of inherent robustness that it promises, machine learning has made inroads into many, many user-facing applications like the ones that I listed before. It's a vibrant area of research, and it's also connected to many, many other related areas. It's intimately connected with artificial intelligence. So I see now that my screen share has stopped. So let me stop sharing and try again. So as a word of, as a matter of procedure, I expect that there will be many such technical issues, and we'll deal with it as they come along. Anyway, so as I was saying, machine learning is an active area of research, and it's intimately connected to many different fields. It's closely tied to artificial intelligence, where the goal is to build or envision or hopefully learn, or build adaptive systems or any automated systems that are as intelligent as humans. So there is a bar, namely human intelligence, and the goal is to build computational systems that cross that bar, or at least match that bar, ideally. But today we are hoping to approach that bar. Machine learning has strong theoretical underpinnings. It is built upon ideas from theoretical computer science and mathematics because we want to understand what it means to learn, and we want to understand this formally, and mathematics will be the tool. In particular, probability, statistics, linear algebra, and theory of computations will give us the tools for this formalization. There are also connections to philosophy and psychology and neuroscience and linguistics because all of these fields have one way or another talked about what does it mean to generalize. And of course, machine learning has many, many application areas. There are applications in AI, like natural language processing or computer vision or robotics and so on. There are applications in medicine. I see that I have listed medicine twice because clearly that's important in my head. There are applications in psychology, in marketing, in economics, and many, many more. And in some sense, it makes me very happy to look at the diversity of backgrounds that we have in this class right here. One of the somewhat sad aspects of this sort of an Zoom-based class is you don't get to see each other in a classroom. But since I just spent a little bit of time looking at what departments many of you belong to, it's cool to see what a diverse set of intellectual backgrounds all of you are from. So let's spend a little bit of time talking about what the rest of the semester will look like. The main question that we will be coming back to again and again throughout the semester is, what is learning? We will answer this question in many different ways. Different formal answers to this question will give us different families of learning algorithms, different specific learning algorithms that some of you may have heard of. More importantly, answering this question in different formal ways will give us the tools to invent new learning algorithms if necessary, and think about whether a certain learning algorithm has certain properties that you might want. Along the way, we'll see different kinds of models. We'll see different learning protocols. We'll see different learning algorithms. We will spend some time on computational learning theory. And a question that will keep coming back again and again is, how do we represent data? So let me go through these one at a time. We will see different kinds of models. A model is, I put that in quotes in the slide because this word means different things for different people. As far as I'm concerned, a model is a function that the learner learns. Like in the badges game, the condition that, not the condition, the rule that you may have thought about was a model. We'll see different kinds of models. We'll see decision trees, which are essentially, you can think of them as rules, and they have an intuitive, they have a nice intuitive explanatory power. We will see linear classifiers and linear regression or linear regressors. These are all different kinds of functions. We will also spend some time on nonlinear classifiers. In particular, we'll spend a fair amount of time on neural networks. And if time permits, we will talk about how we can get nonlinear classifiers using kernels. We'll spend time on not just individual models, but we'll talk about groups of models that interact with each other, or ensembles of classifiers that together as a consensus make a prediction. And hopefully at the end of the semester, all of these things will make sense. There are different learning protocols out there. So very briefly, in supervised learning is a protocol where a teacher supplies a collection of examples with labels, like that table that I showed you. And the learner has to learn a function or a model, using the word that we just saw. The learner has to learn a model that can label new examples. What I asked you to do in the badges game that we saw was essentially a toy version of supervised learning. There's also unsupervised learning, where there's no teacher. The label has just unlabeled names or examples. Think of in the badges game, you just get a ton of names, and your goal is to discover a function that I may have had in my head. You don't even know what plus and minus are. In some sense, what unsupervised learning will give you is it allows you to discover regularities in data. And it's the, if you're interested in this, there are other classes. We'll spend only a limited amount of time, if any, on unsupervised learning. But the data mining class or the clustering class, if it's offered, will tell you a lot about unsupervised learning. Now, you don't have to divide life into supervised or unsupervised. More practically, what usually happens is there are some labeled examples. You have some, again, just using the badges game as an example, there are some names with labels, and there are other names with no labels. And the goal is to somehow use any regularities in the unlabeled names and the signal from the labels to together to come up with a rule or a function that can label new examples. Another learning protocol, and by the way, the difference between all these learning protocols is how a learner interacts with data. Another learning protocol is active learning. In active learning, the learner and the teacher get to interact with each other, which is in general, which can be more efficient. The learner can ask questions. Active learning is efficient both for in terms of it's efficient in terms of how quickly concepts are exchanged between a learner and a teacher, both for programs and for humans, which is why I would like to encourage you to ask questions, not just now, but as we go along. Active learning is something that it's a protocol that allows faster um, uh, transfer of concepts because you get to ask doubts. Reinforcement learning is another learning protocol where a learner gets to interact with an environment where, for example, a learner would, this is, for example, a self-flying helicopter might employ reinforcement learning by trying to fly. And if it's falling, if it detects that it's falling, that is in some sense feedback that it's not doing something right, and it tries to learn from that feedback. In general, for pretty much most of the semester, we will be looking at supervised learning. So another quick poll: how many of you have seen supervised learning before? And while you answer this poll, let me answer the question that came up in chat. In reinforcement learning, does the learner interact with the teacher? Maybe, maybe not. In like the simplest kind of reinforcement learning, there is no teacher. The environment is the teacher. And the learner gets to, in some sense, play with the environment or play in the environment to collect feedback and figure out how best to navigate the environment. So there need not be an explicit teacher. The other question is, so there are a few questions, I'll go in order. Where do I think you meant generative adversarial networks fall? It's an interesting question. Typically, these things fall under supervised learning because since we have not spent any time talking about GANs, I'm not going to talk about it too much, but there is a discriminator and a generator, and there's usually some label data that allows, that is needed to even start the process. So it would fall under supervised learning but there are certain tweaks that would take it to semi-supervised learning. The other question is, how do we know which learning method to use? Does the data determine this? And I think what you meant there is, how do you know which learning protocol to use? And the answer is yes, the kind of data that you have definitely determines this. If you have labeled examples, then there's nothing stopping you from using supervised learning. If you have no labeled examples, then you have to think about what to do next. You could think about using unsupervised learning or clustering, but there's a technical difficulty there. So imagine that I just give you a bunch of names in the badges game and said, learn. Now that by itself is an underspecified problem, because maybe you discover a regularity in the data that doesn't match the function that I have in mind. So purely unsupervised learning might allow you to, different learners might come up with different models with unsupervised learning. So it's useful to have some supervision. Semi-supervised learning is a practical in-between thing. So you have a little amount of labeled data, so you can use supervised learning, but you have a ton of unlabeled data, so you can use a mix of supervised and unsupervised. Another aspect that determines which protocol you can use is, frankly, how much money you're willing to spend. If you have a lot of money, you can just hire people to label data. But sometimes that may not work, because what if nobody knows the thing that we are trying to learn? Or what if the person who has to label this is going to charge a lot of money? So as we go along, we'll mostly spend time on supervised learning, but in some sense, the amount of data that you have determines which learning protocol you'll use, and the amount of resources you're willing to commit. And most often that translates to money, to either collect data or pay people to participate in active learning, or sometimes none of these are going to work and you just have to learn from demonstrations. At that point, you have to use reinforcement learning. So so let me just, I'm going to end the poll. And it seems like about 3/4 of you have either used or seen supervised learning before, and the rest of you have never heard of it. In either case, my hope is at the end of the semester, all of you are very, very comfortable at least with supervised learning, and to the point where you actually implement your own learning algorithms and maybe even want to invent some of your own learning algorithms. Speaking of learning algorithms, there are many different kinds of learning algorithms. There are many different learning algorithms, but even more so, there are many different kinds of learning algorithms. So, um, so there is a question from Kyle. Many of our projects show semi-supervised learning. We are expected to create. Yeah, that's an interesting analogy. I've never thought about this, but thanks. That's an interesting analogy. Yeah. So there are many different kinds of learning algorithms. One group of learning algorithms are called online algorithms, where the learner can access one or a very small number of examples at a time, do some processing with it, and then toss away the example because it doesn't have the memory to keep everything. Perhaps one of the earliest learning algorithms that exists is called the perceptron algorithm, belongs to this family. So in some sense, the idea is the learner in perceptron, the learner will get one example, it has to make a prediction, and then based on its prediction, it gets a reward or a punishment, and based on that, it has to update itself, it has to learn. And there are, of course, more modern online algorithms. We'll be looking at perceptron in quite a bit of detail. You'll implement it, and we'll look at some variants and such things. Today, more often than not, most of the time when people use learning algorithms, they use what are called batch algorithms, where there is a fixed data set. This is all the data there is, and this is all we have. And the learner gets to access all of it. It can load all of it into memory or play with all of it, do what it wants with it. And at the end of this whole process, it gets to it has to produce a model, a function, a rule, if you want. Many different algorithms are batch algorithms. Naive Bayes, some of you may have heard of this, support vector machines, logistic regressions, nearly all modern neural networks, decision trees, nearest neighbors, boosting, all of these are batch algorithms. We'll be looking at all of these in some amount of detail. The most common technique for creating unsupervised or semi-supervised algorithms rely on strategies like expectation maximization or clustering-based methods like k-means. Some of you may have used some of these algorithms as black boxes in the past, and my hope is to, over the course of the semester, you'll understand the insides of these things, and to the point where you can implement almost all of these algorithms that are listed on this page. We will revisit this at the end of the semester to kind of get a checkpoint of how far we've come. A question that will keep bothering us along the way, all through the way, and even beyond is, what's the best way to represent data? What is it? So in the example that with the badges game, the suggestion that was made involved this thing called vowels. How do you know what a vowel is? How do you know that the rule involved looking at the length or at the characters in the name and not the font that was used? So this is a problem this is a crucial problem. If you have the right features, if you have the perfect features for learning is actually very easy. Machine learning, from a computational point of view, if you have perfect features, is very easy. But how do you know what aspects or attributes or features of examples we should look at? How do you know we should look at vowels or the length of the name or such things? This is something that is, in some sense, a design question. A modern twist on this design question is the following. I don't know what the right features are, but let me provide the input at the lowest level of granularity, just characters or pixels, and learn these features from data. So now my learning problem is not just to learn the function that is hidden, but also the underlying the attributes that were needed to look at these that were needed to produce that function. This is in some sense the basis of modern deep learning or neural networks that some of you may have heard of. Another related aspect here is also dimensionality reduction. We'll cover this if time permits, but I've been saying this for the last 6 years and I've never once had the time to actually get to that. So we'll see how it goes. Now, along the way, all of this, the entire class is in some sense structured around the theory of machine learning. We'll keep coming back to this question of what does it mean to learn? We'll answer this question in 3 different ways, which will give us 3 different families of learning algorithms. One of them is online learning, where the learner gets to see examples in a stream, and the goal is to stop making mistakes as the learner sees more examples, or maybe to minimize regret in hindsight. Another version of another way to answer the same question has this really cool name of probably approximately correct learning, which where the underlying philosophy is there's no hope that we can produce a perfect function. There's no hope that you can read my mind and produce the rule that I had in my mind. The only hope you'll have is to produce a function that in the future, with high probability, will not make too many mistakes. Formalizing this gets us what is called probably approximately correct learning, and it leads to a whole bunch of learning algorithms that are practically used. There's a question, how is online learning different than using a batch size of 1? These are phrases that I'm sure not everyone understands, but I will just briefly explain this. The big difference is in online learning, you don't get to revisit an example, or you don't get to control which example comes to you. You think of this as a streaming setting. You just get examples one at a time. Nature provides one example to you, and you don't get to go back in time and revisit an example you saw earlier, because that is done. You see an example, you make an update, and you throw out that example, and you never revisit it. And whereas in standard batch kind of settings, we get to loop over examples again and again. There are no epochs, yes. The third sort of theoretical perspective we'll look at for understanding what does it mean to learn is a Bayesian perspective. It's a probabilistic perspective, where instead of thinking about producing a single model, we can envision a probability distribution over all possible functions that produce the examples, and try to characterize that distribution, or maybe try to find the most probable function. We'll encounter all of these 3 things. Now, the point is, I said a lot of words today that maybe you're not familiar with, and just because you're not familiar with it doesn't mean that the rest of the class will not make sense, the rest of the semester. The point is, in some sense, if you didn't know anything if everything that I said today seemed troublingly complicated, you're in the right place. The goal of the semester is to understand all of these things, or most of these things, and more importantly, focus on the underlying concepts that led us to take this up, that led us towards all these algorithms. And we'll focus on the underlying concepts and the algorithmic ideas that span machine learning broadly. It's not about a single specific learning algorithm. It's not about a single specific learning tool or a single specific way of thinking about what's learning. Instead, it will give you the set of a broad theoretical understanding of many different paradigms for learning and many different algorithms. Along the way, you will implement many of these learning algorithms for your homeworks and for your project. And through this process, you will hopefully understand where machine learning can be applied, where it's not necessary, and you'll also gain the skills to make appropriate choices about what algorithms to use, what kinds of models to use, what kind of supervision is most appropriate, and so on. This is the goal of the entire semester, We'll revisit this again at the end of the semester and see where we were. So this is the technical part of today's lecture. The next thing is how we will learn, or how or what the mechanics of this whole process are, and this takes us to course information and the logistics. So before I go here, are there any questions about anything technical? I'll wait for a few seconds and you can type your question on Canvas, or just raise your hand and ask the question. There was a question, will we be discussing ethical issues related to machine learning? Absolutely, yes. This is an important topic. I'm hoping that there will be at least an entire lecture, or at least half a lecture devoted to that. Most likely it will come towards the end, where these things will, where you'll have some grounding on the technical concepts we'll discuss. But this is thank you for asking that question. This is an important point, and I really think we need to think about the ethical aspects of machine learning. We need to have that in our heads when we are using these technologies. There's another question. Are there similarities between NLP and machine learning? Now, let me answer this question first, more from a selfish point of view. My preferred application for machine learning is natural language processing. But in some sense, natural language processing involves understanding or building programs for that can reason about language as if it was human. Now, perhaps the most important tool for natural language processing is machine learning, and it has been so for the last maybe few decades. But natural language processing is an application as far as machine learning is concerned. I wouldn't say there are similarities between these two. Machine learning is a tool that is used for natural language processing. Natural language processing involves a phenomenon, namely language, that in itself is an area of investigation. But natural language processing is perhaps the most important, machine learning is perhaps the most important tool for NLP today. Okay, if there are other questions, keep them coming. If not, I'm going to talk about logistics. So basic information, the course website is on the slide right now. I also posted a link to this on Canvas. This is where the lectures and such things will be posted. The class itself is going to be, the lectures are going to be streamed via Zoom. Most of you, almost all of you are on Zoom, so that's there's no reason for me to explain more. The lectures are also going to be live streamed on YouTube, but there will be maybe about half a minute lag on the YouTube thing. YouTube itself has its own chat, and one of the TAs is monitoring that. And if you have questions, I would prefer that you ask the question on Zoom, because I get to see it also. But if you have questions on YouTube that you want to ask on YouTube, please feel free, and one of the TAs will bring it up to me, or they'll answer it themselves. So we will be using Canvas for anything where you have to interact with me or the staff, so, or with each other even. So we'll be using the Canvas discussion forum. All of you should have access to Canvas by now. If not, you'll get it very soon. There's a link to Canvas, the Canvas discussion forum on the class website. This is the class website. And the class will be, the Canvas will be used for announcements and managing submissions and grades and such things. Another thing is that the class is recorded. This way, not only is it streamed live, it's also recorded, and the lectures, the videos will be available afterwards. This will hopefully help you catch up with things in case you missed something, or it will help you with revising material or just revisiting the lecture at your own pace. Even though the class is recorded, I strongly encourage you to try to attend the class live. There are a few different reasons for this. It makes sure that you don't miss anything, or it allows you to clarify things by asking questions. And it also gives you access to the chat where the interesting suggestions come up. And the chat is not going to get archived. So in some sense, I'm thinking of the chat as a classroom discussion. So please try to attend the class live if you can do it, rather than watching the video afterwards. But the video is going to be available anyway. In terms of who and when, the lectures are on Tuesdays and Thursdays from 9:10 to 10:30 a.m., not p.m. So that's important. Technically, I have an office, but I'm not going to be there. The office hours will all be on Zoom. The URLs for the office hours were sent as an announcement on Canvas, and they are on a page on Canvas where you can find them. My office hours will be at 10:45, right after class on Tuesdays. There are 3 teaching assistants in the class who are also eager to help you out. At this point, I would ask you to, just unmute your videos so that the class can see you and you can say hi. There is JD Adams, there's Ashim Gupta, and Mattia Crespan.
Yeah, hi.
And I don't see Ashim. Ashim, are you there? He's there. And all of their office hours are on the slide. They're also on the class website and on Canvas. You can mute yourself if you want and mute your videos. All 3 of them have taken the class before and have done well. So, they'll be able to help you out, and they are eager to meet with you during office hours. So please attend their office hours. All office hours are going to be on Zoom. I'm going to mute Ashim and Mattia just so that there's no interference. All of us are happy to help you out, and we are eager to help you out. If to streamline this, I strongly encourage that you use the discussion board and the Canvas email as primary media for communication. Unless, of course, there's anything confidential or personal, please do email me if you feel like you don't want to use Canvas. But I strongly encourage that you use Canvas. And even if it's something confidential, you can use the Canvas email to send a message to me, and that is others can't see it. The thing about email, just not Canvas, but email by itself, is the turnaround might be longer. Just to make sure that I don't miss any emails, if you're going to send me an email directly to me without going through Canvas, please prefix emails with the class number, with the caveat, of course, that the turnaround will be a little longer. If there are any announcements, I'll be using Canvas to make an announcement like the one I did this morning, just welcoming you. In terms of the mechanics and such things, I'm assuming that all of you hopefully have seen basic probability and statistics at some point. You've encountered linear algebra at some point, and you should have enough computing skills to be able to implement the algorithms that we'll see in class and reason about them. All 3 of these are helpful. There's no required textbook. The class is self-contained. Any material that you need will be made available through the class website. When I say class website, I mean this URL here. And there are also a growing collection of resources on the website that will help you with the prerequisites. In terms of what you'll be doing to earn your grade, a bulk of your grade will depend on the assignments. There will be maybe, I'll talk a bit more about assignments in a bit, but 65% of the grade will be based on your assignments. 10% of it will be based on the final exam. And there will be a class project which will account for a quarter of your grade. A question that comes up often is how this class involves both grad students and undergrads, and how will these 2 groups be separated? grad students will have to do a little bit more work in each assignment or in most assignments, and they'll be treated as a separate group when grades are assigned. So grad students and undergrads are graded separately, or at least curved separately. Sometimes undergrad students feel that things are overwhelming because there are grad students here and there are people who are doing their PhDs and such things. And to you, I say, don't worry. Invariably, among the top 3 performers in class overall, even without any curve, there has always been at least one undergrad every year that I've taught this class. So it's doable. That said, that's a fair amount of work. I'm not going to try to make it easy for you just because the class is online. I feel like that's not fair to you. In terms of homeworks, there will be 6 or 7 homeworks in all, roughly one every 2 weeks. Some of these homeworks will be week-long quizzes that you can do on Canvas. Some of them will be things that you have to implement. Some of them will involve doing some math. Grad students will have extra questions in some of these homeworks. Many of these homeworks will involve a programming component, and your code that you submit must run on CADE. We strongly prefer Python. Technically, I'm going to allow the other languages, but I would, if you cannot use Python for some reason, like you're not comfortable with it or you've never encountered it before, don't bother trying to learn Python also in addition to machine learning, but please ask me if we can we support that. The reason is, while I don't mind allowing you to use another language, I want to make sure that we can provide you the support, in case you get stuck. So there was a question on chat: is there a specific version of Python you need us to work in? As long as it runs on the CADE machines without us installing anything, it's okay. I believe both Python 2 and 3 are available on CADE, and there is instructions on how to access CADE if you're not familiar. There's a frequently asked questions on Canvas. I don't remember which version of Python is available. In general, I would recommend, if you're using Python, use Python 3 because 2 is not supported and will not see too many more updates. So as a general suggestion, advice, I would say use Python 3, but for the class, use whatever is available on CADE. I think both are available on CADE. All your submissions have to be digital. This is true even more so this year than usual because there's no way for you to hand me anything. Everything has to be via Canvas only. As much as possible, please don't try to email me or the TAs your submissions, because that might overwhelm our inboxes and we might just lose track. So we'll have submission windows on Canvas that you can submit to. For any assignment, or actually not just assignment, for any submission throughout the semester, we will accept submissions that are up to 24 hours late, provided you're willing to give up 10% of your grade. So if you had received 90% on some assignment, but you submitted it within the 24-hour window, your 90 will become 81 because you lose 10%, which is 9 points. After 24 hours, we will not accept any more submissions. And this late policy is available for all assignments. It's available for everything except the exam, really. There's going to be a semester-long project. The goal of the project is to show what, show you, show yourself, show me, show everyone what you've learned. And the idea is that you use concepts that you have seen in the lectures and in the homework and do something interesting. We'll be using what in my mind I think of as a competitive project, where all of you will work individually on a data set that we provide and compete for position on a leaderboard on Kaggle. Your position on the leaderboard is not going to determine your grade as long as you do all the right things, but multiple students have told me in the past that the fact that there is this competition, even a kind of a competition just for pride, if you want, makes it more interesting. I'll let you know what data set, what task you'll be working on as we go along. But there are many milestones for the projects. Please see the class website. I'm highlighting it on the slide. There's a link to it on the class website also for more details about the project milestones. An important milestone that's coming up about a few weeks from now is when you have to give me project information, where you will just download a data set that I will provide and create an account on Kaggle and share your Kaggle details on Canvas so that we can tie those two accounts together. Are there any questions about homeworks and projects? Will the solutions for the homeworks and the projects be released? Technically, the solutions for the project will not be released because as the submission date for the project is literally the last date for the last day of the semester. But of course, the solutions for the homeworks will be released, provided it's as soon as everyone submitted, basically, and as soon as we have made sure that the solution is clean. There's some technical issue involving the name data for the badges game. Can you post a discussion message on Canvas, and I'll me or the TAs will add a pointer. Basically, if you go to the syllabus page and click the link for the first lecture, there's a link to the badges game there. Yes, that's where it is. Are there other questions? Is there a particular IDE you would recommend for Python coding? Not really. I don't really recommend. I have discovered that my recommendations for IDEs are often laughed at, so I'm not going to even attempt it. I don't recommend an IDE. One thing that I have found a lot of students use is some Jupyter notebook or something like that, where you submit the Jupyter notebook. That way you document your code and you make it easy for us to run. So I will allow Jupyter IPython notebooks to be submitted for homework. Otherwise, I don't really care about an IDE. Use an IDE as anything that works. The other question is, we aren't proposing our own projects for the final projects, and rather you'll be competing on the task. That's right. In the past, I've allowed some students to propose their own projects, but this led to some mismatch in grading, I feel, where a bulk of the projects were of one type and a few were of another. And so to kind of equalize this and make things a little bit more streamlined, I have decided that this semester you'll be all working on the same data set, and I promise I'll try to make it somewhat interesting. Any other questions? If there are no other questions, do the TAs have office hours? Yes, the TAs do have office hours. I'll pull up the slide. So I'll have office hours on Tuesday, and JD's office hours are on Wednesday. Ashim's got his office hours on Monday, and Matthias on Thursday. What this means is 4 out of 5 days in the weekday, we are available to help you out. So please take advantage of that. All right. In terms of other policies, there's a lot of information on the class website here. So please take a look. What I'm going to go through is just a brief discussion of think of this as the highlights of these policies. But there's a question: is there going to be a midterm exam? No, there's not going to be a midterm exam. Instead, there'll be. I used to have a midterm exam in the past, but instead, because it's all online, I'm going to have an extra homework that you can think of as a take-home exam if you want, but it's going to be just accumulated in the homework file. So this class operates under the School of Computing and the College of Engineering policies. To find out what this means, there's a pointer on a lot of these about a lot of these things on the class website. In particular, it operates under the School of Computing policy for collaboration and cheating. Collaboration is strongly encouraged, but there's no point in cheating. Cheating will not be tolerated. I'm assuming that all of you are here. This is an elective class. All of you are here to learn something useful, and essentially cheating makes it hard to, uh, it ruins the experience for everyone else, and it also basically makes it pointless for you. There's a question about CADE, and yes, this is a computer lab and you have remote access. There's an FAQ entry on specifically this. You should be able to get yourself accounts on CADE. Yes. The School of Computing has a policy on academic misconduct. Please see the link on the website. Basically, what it means is you need to do your work by yourself. All your submissions should be your own. Nothing is a group submission. You need to acknowledge your sources and any discussions you may have had. Let's create a respectful environment so that everyone gets to learn. I'll get to the point about waitlist at the end, Shyam. In terms of accessibility and accommodation, I'll be happy to provide any assistance on this, but please contact me as soon as possible, because these things take time. I'll be relying on the university's Center for Disability and Access to provide assistance. So if you need any assistance, please get in touch with me, and I'll start the process ASAP. There are a whole bunch of other policies on the class website and information involving safety and such things. I'm not going to tolerate any kind of harassment or discrimination in this class. So if that happens, I'll probably have to ask you to leave. If you need any assistance with respect to wellness or health, please contact wellness.utah.edu and they'll help you out. There are a lot more details on the class website, so please read it. Please read the information page on the class website, because it has a whole bunch of details and if there are questions, contact me. There's another question about CADE. You don't need to access it remotely. Yes, thank you, Megan. There are, in fact, I would suggest, honestly, I've been teaching this class for many years now. I'm still a little bit unsure about where the CADE labs are physically, because I've only accessed the machines remotely. If you need help with that, we can, I can point you to the CADE website's, instructions on remote access. So this is pretty much most of what I have to say today. One thing I would like to know is who you are. There are about 120 people registered for class. I see 110 of you on Zoom and more of you on YouTube. So there's going to be a survey that should be available on Canvas maybe in 10 minutes. That just lets me understand who you are, what your interests are, what your background is, and what you think you want to learn from this class. And also any suggestions you may have for streamlining this class, making this remote instruction more efficient, and so on. So please answer the survey if you want to. It's completely optional. You can choose not to answer anything or not. It's going to just help me and the TAs kind of streamline things and design the lectures for you, so for your interest. So just to wrap things up, a few announcements. Because we are already at the end of one lecture, there's going to be a quiz on Canvas. And then I think it should be available maybe at the end of this class. It's due in 1 week. It doesn't cover anything that I covered today. It covers the prerequisites. The goal of this quiz is to refresh your memory about prerequisites, and if necessary, point you to resources or make sure that you have access to resources that you will need so that these ideas, when we encounter them in class, you know where to look. This class is oversubscribed, both on the graduate side and undergrad side. If you are unable to register, please attend the first few lectures as if you're registered, and as space opens up, I'll give out permission codes for the grad students. For undergrads who are not registered and maybe are watching this, the recording of this, you will probably get added to the class as space opens up. So that's all I have. Please fill out the survey on Canvas. It will really help me out. And today, and pretty much the only time this semester, I will actually stop this class earlier, and you can use the time to fill out the survey. There's a few other questions, and and after that I'll stop. So I can't find the link to Kaggle on Canvas. It's not yet there. I'm still in the process of setting it up, and I'll post a link on Canvas maybe in a few weeks. There's another question or a suggestion. The class discussion may not. Okay, so this is really a message for me, and John, you can reach out to me by email. Do we have to use CADE? I've never had access to CADE before. It just makes life easier for grading because it will help us understand. It helps us kind of normalize the computing environment across the class, and that way everyone gets to use exactly the same resources. You don't have to use CADE to write your code. You don't have to use CADE to debug and such things. You can use your laptop for that, or any environment for that. All you need to do is to ensure that when the TAs are actually running things, your code actually runs on CADE. So you can just run your code on CADE to make sure that everything works. You don't have to use CADE for development. Accessing CADE is not particularly hard, I hope. And if it is, we can help you out. Quiz 0 will be counted towards the assignment scores, but it will count like maybe 1% at the end. It's a small quiz. It should ideally not take you too much time. There's a question about what shows up on Canvas. Yeah, so on Canvas, all of you are inside a class labeled 6350, which is the graduate class. This should not matter. When the assignments show up, you'll be able to, so certain questions will be marked as only for grad students, and you can just skip them. So it doesn't really matter. It just makes the logistics easy for us. Everyone is inside this one bucket called CS6350. But I know whether you're a grad student or undergrad. Any question that is marked as for grad students only, undergrad students can skip them. There's some suggestion about CADE, and I agree with you, Alex. Parth asks if the questions are timed and can we retake the quizzes. If the quizzes are timed and if you can retake them. No, the quizzes are not timed. You can definitely retake them. Usually what I do is I allow you to retake quizzes. I give you 2 tries. After you do the quiz the first time, you'll get to see which questions you got wrong, and you can do it again. The way I think about it is all homeworks and quizzes and everything is to make sure that you get the most out of this class. That way you get to see which questions you got wrong, and you can come to us and talk to us, and we'll help you out, and that you get to learn more. There's no point in timing the quizzes. I'm still not entirely decided on the final exam though. So everything I said with respect to timing is only for quizzes. The final exam might be different. I mentioned this before. There are no midterm exams. Yes, you're right. I see there are a lot of useful suggestions on accessing the CADE lab. And I think in the interest of keeping this discussion permanently, maybe there can be a discussion thread on Canvas where these suggestions can be posted, because that way people can see it even afterwards. But thanks, Ryan. And I've used No Machine, and I have also found it to be useful. All right. Are there any other questions? It seems like there aren't any. So at this point, I'm going to stop, and I will see you all on Thursday. There's a question about what % of time XGBoost is not the best supervised algorithm. I'm actually going to take that question much later when we come to boosting and such things. And as we come along, the short answer is we don't know. And hopefully at the end of the semester, you will agree with me. So yes, I will be starting my office hours in 15 minutes. It's a different Canvas, it's a different Zoom meeting. So I'm going to sign out of this and stop the meeting for everyone, and we'll get there. I'll get there at 10:45 Mountain Time. All right. Thank you all for coming to the first lecture, and I hope to see you all for the rest of the semester. And I'll stop the meeting right now.